But first we have to know kind of how the solar system was first made. Well, it's all due to gravity. Everything with mass has gravity, and it pulls things in towards each other. So when we were first a nebula, which is just a big, gigantic dust storm in space, we started to form clumps. I mean, think about it. Does anybody have like a tile floor at their house, like a big one? I have a huge tile floor in my kitchen. Like, do you ever wonder how in a small corner it has dust or little animal hairs or something? It all gets on the corner in this little dust ball, like a dust bunny they call them. Well, it's because, things eventually come together and they stick together. Well, in outer space, that's what happened. All that dust started to clump together, forming rocks. Those rocks started to clump together, forming planets. That's how all the planets were formed, through that clumping process. Okay, from those dense clouds. That's how the solar system formed, spinning around, gas and dust, ultimately coalescing with the largest mass in the middle being the sun, and the rest forming around them being the planets. That's how the solar system's formed. Now we have inner and outer planets, for our solar system. And we've already talked about them, but we're going to go a little bit more in depth about our inner and outer planets. Okay, the inner planets they only take up a small portion of the solar system. They only take up about 1.5 astronomical units. Very, very close. Remember, when I talk about close in outer space, I still mean really, really far apart. But in terms of the solar system, they're relatively close together. And they're not very big. They're kind of small compared to the other planets. And they're rocky. The first one is Mercury. It is the smallest terrestrial planet and the closest to the sun. Still pictures. Now look at the size comparison of Mercury to the Earth. It's about the size of the moon. So it's not incredibly big. Okay, but it is still considered a planet, and it's the closest one to the sun. Its rotation around its axis is extremely slow. That means one of its days is actually like 240 of our days. But it's so close to the sun that it revolves around the sun much quicker. It only takes about 88 days to revolve around the sun. So if you use the definition of a year, meaning how long it takes for the planet to orbit the sun, its year is less than its day. That means one side of Mercury is always extremely hot, and the other side of Mercury is always extremely cold. So that's your Mercury. Venus. Venus is considered our sister planet because it's very similar to us. Now the camera right here shows you, from the outside, you have this huge, very thick atmosphere. It doesn't let any of that heat from the sun escape. So it's constantly getting hotter and hotter. Our atmosphere allows for the sun to hit the Earth, and then most of that heat bounces back off into outer space. For this planet, it hits it, and then it hits the atmosphere and bounces back. So it's constantly getting warmer and warmer. So if there was any water on this planet ever, it's long since boiled away because of that heat. Now look at the composition. It looks very similar to Earth once we get our radar through those clouds. The size comparison, they are very, very similar in size and composition. That's why we call it our sister planet. But once again, its thick atmosphere traps most of that heat that the sun is giving. Even though Mercury is closer to the sun than Venus, Venus is hotter because of its atmosphere. The Earth is our favorite planet because we live on it. It is the only planet in the universe that we know of that has life. Now, that doesn't mean it's the only planet with life, but we have not discovered any yet. So we can't say there is. Earth is the only planet that we know of that has life on it. We have a core, an iron core, which is spinning, which causes our magnetic fields, which protects us from solar radiation and solar winds. Okay, we have the outer core, we have the mantle, and then we have the crust. The mantle is liquid rock. Okay, it's basically lava under the ground. The mantle is hardened rock. So that mantle is actually floating on top of a liquid like a raft floating on water. And so they're constantly moving. That's how we get earthquakes. You have two plates, two crusts right next to each other, and one is moving this way, the other's moving that way. And when they slide past, that friction causes the ground to shake. That's an earthquake. Sometimes the magma finds a way out, okay, through little fissures in the earth. We call those volcanoes. That's why if you look at North America and Africa, it looks like Africa is just a puzzle piece that got pulled away from North America. It doesn't just look like that, it is like that. That's called plate tectonics. We are pulling away from Africa. Eventually, since we're a sphere, we're going to collide with the other side. Now, it's not a collision like cars. Okay, it'd be a very slow collision. And when two plates collide, they hit each other. And if you put your hands like this and keep pushing, what eventually happens? Those are mountains. That's how we have our mountain ranges. It's two plates colliding, pushing up. And now we have mountains. Okay? Yes, and you can't have one that slides under, and this crust actually gets recycled. It gets melted and recycled over it. Okay? All right, moving on. Whenever I ask my class the first time about which is our sister planet, everybody always says Mars. Okay, that's not the case. Okay, but Mars is our number one choice if there was possibly life on it. And that's because we noticed when we look at it through pictures, we notice there are little ravines. It looks like water used to flow on the planet. In fact, when we first discovered Mars, the scientists who first looked up at that didn't have that great of a telescope, but Mars, the rivers, the ravines, were so easily seen, he called them canales. Okay, canales just means a place where water flows, and we get that's where we get the word canals from. So he used the word canales, and everybody thought he meant canals, and we all know that canals are man-made, so they thought he was saying there are Martians up there. There are people living on Mars because the only people that can make canals are intelligent beings. And that's when the big old Martian craze started to happen. That's what the word Martians are. Martians doesn't mean any alien. It means aliens specifically from Mars. Okay, that's what Martians mean. But we know after even sending a couple rovers down there, we don't see any life at all. But what is intriguing is it does have caps, a polar and a northern and a southern polar cap. A cap. And so it is ice right there on Mars. Okay, so we figure if there's ice up here, then possibly the water that was on the surface possibly went underground, like a well. I mean, there's a lot of people that go around on Earth looking for wells. And there's companies that go around, surveyors, that find wells for people looking for a place to live, and they want a real spring. Okay, so they're thinking maybe possibly underneath the ground there is still flowing water. But we have no idea. Jupiter is one of the gaseous planets. Now we're looking at our larger planets. Jupiter is the largest planet, and it is mainly made of mostly hydrogen and helium. In fact, a lot of people think that Jupiter was on the verge of becoming a star, right? Because it was getting so massive, and once again, it's made of hydrogen and helium, just like most stars are. But it didn't get big enough. It didn't have enough energy for that to happen. Okay? In fact, Mars creates enough energy on its own to heat itself up. So, like, if the sun went away, Jupiter could still, survive because it produces its own heat, enough heat to survive without the sun. And so when people look at other solar systems, they always look for a giant planet like Jupiter before they start looking for a planet that could be like Earth. Because, like they said, it acts as a gigantic magnetic field that pushes and deflects incoming asteroids. So it's our protector. It's there. Without it, we'd get hit so much that we wouldn't be possible. Okay? Getting smarter and smarter and smarter, and bam! You're all gone. And then another life form starts getting smarter and smarter and smarter, bam! Now it's gone. not giving enough time to rise to our, our intelligence. Because every time something starts becoming smart, something hits it and boom, they're gone. So Jupiter allows us, to get to the part where we are. So if you start looking at are aliens possible, you always have to look, is there a planet like Jupiter that acts as a protector? Saturn's pretty. It has rings. All of the gas planets have rings, but Saturn has the most prominent. And it's basically just junk. It's dust and debris and space rocks that just get caught up in Saturn's magnetic pull. A lot of ice in there as well, and it's constantly being replenished. The inside part is being sucked into the planet, and then the outer part is constantly getting refilled. Think of it as the hoarder of our solar system. Kind of like that, that family member that won't throw away bags, right? Because we're going to use them eventually. Type of person. Okay, that's who Saturn is. It never throws anything away. We don't need to talk about Saturn. That's basically all I need to know about Saturn. But look at the size difference. There's Earth. There's Saturn. Okay. Now here's Uranus. Okay, Uranus is a giant gas planet as well, about 4 times the diameter of the Earth, and it's smaller than Jupiter and Saturn. Okay, that's basically all you need to know about Uranus. You don't need to know much about these other planets. Okay, it is completely on its side. Okay, it has a tilt, like all on its side, and it rotates. So imagine, it must have been hit by something huge in order to get knocked off its axis. Okay, it rotates right on its side. It's really crazy. It's the only planet that does that. That's why its rings look like they're vertical. Okay, and it's not like Jupiter on its side. It's vertical up and down because it is actually on its side. That's why. If you tilted it back, it'd look normal. And then finally, Neptune. Neptune is a cold blue planet, and its atmosphere contains visible clouds. And once again, it's way bigger than the Earth. Neptune, it's blue in the sky, so they named it after the god of the ocean. Okay, Neptune. Okay, also known as Poseidon. Okay, if you're looking at the Greek mythology, all the same gods. They just get renamed as they go through. And Pluto, no longer a planet, but look how tiny it is. It's much smaller than our moon, smaller than Mercury. And one of the reasons they don't call it a planet anymore is because it doesn't belong where it's located. If it was formed during the origin of the solar system, a rocky planet like Pluto should have been pulled next to Earth in that small little area. It should not have been formed out with the gas planets. Therefore, we assume it came to us at a later date. So it is not an original planet. So they don't count it because the planets they count are formed during the formation of the solar system. They don't think Pluto is that. They think Pluto was a space rock that got caught up in the gravity of the sun and started taking an orbit. So that's one of the reasons they don't call it a planet anymore. But because I know you like Pluto, I did throw a couple videos up here, but it looks like they don't work. Okay. Question. What's that? If they blew, who? Who? No, we would not spend a whole bunch of money to go blow up a planet. We never blew Pluto up. We have not blown Pluto up. The orbit of Pluto does cross with Neptune, but we haven't sent anything out there to blow it up. I don't think so. If it crashed into Neptune, it wouldn't do much. It maybe tilted a little bit, but it's so much smaller than Neptune. It's like if you get hit by a bee, and it hits you like, oh, a bee. It really nothing. Well, then you're like, it stung me, but that's about it. All right. Okay. Final stuff. Asteroids. Asteroids mainly come from the Asteroid Belt and sometimes they get knocked out, and they get thrown in towards us. And that's because it's kind of like when you're playing pool, right? You hit a billiard ball, and it goes off to the side. Same thing here. It's just an awkward angle. They collide into each other, and it hits it, and it starts going out that way. And it happens all the time. Little asteroids always get thrown to Earth. Okay, notice it's a huge belt right there. It's a huge belt separating the inner planets from the outer planets. Here's comets. Comets have a tail, a nucleus, and a coma. That's all you need to know about it. You need to know that it's the smallest thing that actually has an orbit around the sun. Okay, so when you compare it with the sun itself, Earth, and the moons, comets are the smallest, namely Halley's Comet. Halley's Comet. But mainly you have to know that it's the smallest, plus you have to know it's 3 parts, coma, nucleus, and tail. It does have a gas tail and a dust tail, but if you just call it the tail, you're fine. Okay, I'd never have a question and point here and go, what is that? The dust tail or the gas tail? I just ask, is it the tail or what? That's all I would ask you. Comets have an orbit around the sun. The closer it gets to the sun, it starts to sublimate. Remember, it turns from a solid to a gas right away. That's what the tail is. It's that gas flying off the back. Kind of like, girls, if you're running and you have long hair and that hair flies up, it doesn't fly off your head, right? But it's flying in the wind, it's blowing in the wind. That's what's happening. That tail is just the ice melting and floating behind. So notice the tail is always the opposite direction of the sun. So the tail is always going to be pointing away from the sun. And then it goes back into outer space, it freezes again, freezes, and it comes back. Here's a quick little comet video. Maybe not. It's too small. Okay. And finally, when asteroids leave the belt and actually enter the atmosphere, we call that a meteor. And when it hits the ground, we call that a meteorite. Okay? And so this car has actually been hit by a meteorite. I'm going to show you a video when I'm done with this. It's how people actually spend money on these things. When a space rock falls from outer space and it doesn't completely disintegrate, it turns into a lot of money because they are extremely rare. And remember, things are worth money when people want them. Things are only worth the amount people will pay for them. I mean, think about it. Everybody has gold, and everybody wants to pay tons of money for gold. But what if people started going, I hate gold. Gold's dumb. Then it's going to be worthless. It's only worth the amount people want it for, and people want these things. That car, if it wasn't hit by an asteroid, could probably be sold for about $2,000. After it's hit by that asteroid, that meteor, you could probably sell it for about $200,000. People want things that have been hit by asteroids. Meteors. That meteor itself down there, probably worth about $1,000 a gram. A gram, about the size of a paperclip. Stop doing that. And that has tons of grams on it. You can make hundreds of thousands of dollars off that rock falling from space.